Assalamu alaikum kids. So this right here is a video in which we'll discuss the first step in addition of vectors, which is the scaling of a vector. So at this point, I assume that you kids already know how to draw graphs of equations, right? Maybe linear, maybe quadratic equation. My question to you is, what's the first step in drawing the graph of an equation? The first step is to define a scale for the x and the y axis, right? Likewise, when we draw a vector on a piece of paper, we start by scaling the vector's magnitude. So we start by scaling the vector's magnitude. How do we do that, or why do we do that? Essentially, the scaling of a vector's magnitude allows us to define the length of the arrow, which will represent the magnitude of the vector. So let's take an example of a 20 Newton vector, which we want to draw on a piece of paper. There are various different scales which can be used to define a 20 Newton vector. They are listed right in front of you. Now, some of the scales may be appropriate while others are not. So essentially, it's up to us to define which one's the more sensible choice. All right. So which of the 8 scales are we going to use? Let's discuss which is the appropriate scale. So scales 1 and 2 will not be appropriate. Why? Because as we can see that scales 1 and 2 are giving you lengths which are very long. So 20 centimeters and 10 centimeters, you may not have enough space to begin with in your exam. So hence, no use in using the scales 1 and 2. Then you've got the scale 3. Now the scale 3 is giving you non-integer values. The problem with that is you're not going to be able to draw accurate diagrams. Alright, your scale can only draw up to a millimeter. Now 6.6 centimeters, yes, we should be able to draw that, but 6.67 centimeters, probably not. So you should only use scales that give you non-integer values very sparingly. You should not use them often. So in which case are we going to use a scale that gives you non-integer values? Let's say, for example, you have to draw a 10 Newton and an 11 Newton vector. The problem with this is that 10 and 11 newtons don't have anything in common, or they don't have a common factor. Hence, we are going to have to use a scale which gives you non-integer values. So let's say, for example, if we take the scale 1 centimeter gives me 2 newtons, then the respective lengths of the 10 Newton would be 5 centimeters, and for the 11 newtons, it's going to be 5.5 centimeters. So you're getting a non-integer value, but you don't have any other option in this case. Alright, so again, scales 1, 2, and 3 all are considered inappropriate. Now let's talk about some more scales, scales 4 and 5. Now, as we discussed, you need values in between 4 and 10 centimeters. That's exactly what you're getting over here. Scales 4 and 5, you're getting lengths 5 centimeters and 4 centimeters. So the scale 4 newtons gives me 1 centimeter, gets you 5 centimeters length of an arrow. 5 newtons is 1 centimeter, gives you 4 centimeters length of an arrow, right? So these are the ones that you are actually going to use. They don't give you diagrams that are too small to be inaccurate. They don't give you diagrams that are too large, so you may not be able to draw them on a piece of paper or in your exam. So these are the values that are going to be the most appropriate. And like I said, why? Because they are giving you lengths between 4 and 10 centimeters. More scales are scales number 6, 7, and 8. Now scales 6, why is 6 not usable? 6 is not usable again because we discussed earlier you should not take scales that give you non-integer values. So 2.5 is a non-integer value to begin with. And of course, it's less than 4 centimeters as well. So again, no use using this scale. Scales 7 and 10 again should not be used. Why? Because the vectors or the lengths that they give you to draw vectors are very small. Very small lengths or very small diagrams again lead to inaccuracies. So you're not going to use 6, 7, or 8, either one of them.